Welcome to Science with Miss Steph. Today we are going to explore a classic reaction, baking soda and vinegar, times 10. Okay, as I've already said, I am glad to see you. Rocking out vinegar and baking soda. Okay, so I'm going to put this over here temporarily. I'm not going to light my stove with that stuff on there, okay? That's just temporarily there so that I can bring over all this stuff over here. Carefully and gently bringing over all of my reagents and my full setup so that we can have a wonderful time together. Now, in the month of May, as I've said before, we have a theme, times 10. I'm showing you a 1x sample and a 10x sample. Now, some of you may be wondering, why have I been doing that? Okay, that's so you can really be thinking through the importance of the power of 10. So you can really experience how multiplying something times 10, how adding a zero, how adding your contribution to our work can really impact what we're doing and can really partner with us and bring us forward. So I am, just excited to be able to show it to you in a chemical form, in a reaction, because that's the easiest way to make sure that someone can understand something is to make it visual, to make it real. And that's what we do at Miss Steph Science Club. I say hands-on every day, all day, right? And so that's the kind of teaching that I do for those of you who've never met me and this is like your first lesson with me. You're in for an interesting you're in an interesting time here. It's an interesting thing going live on Facebook. Or really going live at all. If any of you have started to kind of dabble in this, particularly during this time during the pandemic, I'm sure you can imagine that it's an interesting thing for us as teachers and educators and stuff to do what we do and to do it at a distance, and even I'm sure watching my videos, I'm sure it's a peculiar thing because I'm sure you notice that I go in and out from talking to parents, donors, to volunteers, and then to you guys, the kids. And that's just simply because I truly and firmly believe that Science Club is for everybody. And so when you hear me talk, it's important for me that you understand, it's important to me that you understand that it's for you. Whoever you are, however old you are, and whatever you're doing and whatever you do as a profession, this program is for you. And I invite you to engage in it in the best way for you, right? If it's trying this particular investigation at home with maybe your grandbabies, or if it's trying this with your burgeoning physical chemist, or if it's just watching it because you're my cousin, because hi, I know my cousins watch this too. Everyone needs support and everyone needs an opportunity to learn something new every day. And this particular reaction has a special place in my heart because it is like the core of understanding chemistry at any level. You can do this activity with any age group and they will get something out of it. Now, today I am going to go a little high schoolish at one point because we are going to break down and I'm going to show you the chemical reaction, but for, like I said, everybody in the VIP and the cheap seats, let's go ahead and get this going. Hi. Welcome to Science with Ms. Steph. And we're going to get this going. I've got different materials here, lots of stuff. I've got a cup here. And this cup really is going to be so that I can do my just control reaction, just so you can see what happens when we add vinegar and baking soda together. So let's do that now. We're going to break out a level spoonful, okay, of baking soda. Then I've got just plain old white vinegar, okay. This is acetic acid. Now, baking soda is sodium bicarbonate, okay. This is acetic acid. We're going to take, for this reaction again, I'm just doing a quick little let me show you what happens when we add baking soda to vinegar, right? That's all I'm doing here. So let's do this. We're going to go to 20 milliliters. Okay. And like I said, this is just a spoonful. Another level, if you wanted to push this forward, your high school chemistry teacher, or maybe even middle school, you want to push this forward, really get your students to engage in stereochemistry, stoichemistry, all that type of stuff. You can say, okay, let's make sure that we are doing a mass, like we're getting a mass of the baking soda, right? So you can have your students use a balance, all right? But anybody second grade and up can use a graduated cylinder, okay? In my opinion, anyway. I know that sometimes we introduce it late, frankly. To me, it's late. To me, it's late to say let's have fifth graders just now get around to using graduated cylinders. That makes no sense to me. I like to introduce it around first grade. That's just me. If not younger. I have done it with kindergartners before. They can read the line. They know their numbers. They know from 1 to 100, right? So they can look at this and you can tell them go to 20. Where's the line at 20, right? They might not comprehend what 20 milliliters is, but you can tell them to fill it up to the line. And then see, they're introduced to the concept and it's not so like new and crazy for them later. Right? So yeah, so fizz. Okay, we've got our fizz. We know that that's what happens when we add baking soda. Okay, we get this fizz. Now, the thing that we really want to kind of expound upon, or, well, not expound upon exactly, but what we're now wanting to monopolize, okay, and kind of magnify is that bubble action, right? So to be able to see the bubbles for a longer period of time, we essentially have to capture them. That's what our soap is for. Okay, this is a surfactant. Okay, soap is a surfactant. It has a fatty end and a water end. Okay, which is why it dissolves in water and also why it can wash off fatty things like oil, right? Okay, so anywho, inside of this container now, let's go to our whiteboard and find out what's inside of here now. Because when you have a chemical reaction, you mix things together and you get something new. You don't really get back what you put in exactly. They've changed form, and that's what's happening here. Additionally, if you're doing this at home, if you're trying it with me, and this is totally safe to try with me, just, be careful with your eyes and whatnot, but you can totally do this live with me in real time with me, right? So I'm touching this in my hand. It's actually cooling because this is an endothermic reaction. I had some fun yesterday with the conclusion of the 2020-21 school year and our Friday science club that we've been doing. And we hung out and we used this as the base. I'm not going to tell you exactly what we did because that, that's for them, but I'll focus what I'm going to do with you all. So let's up you a bit now and we'll talk chemical reaction, right? All right, so I've got my whiteboard. Let's see how much of the whiteboard you can see. All right. Okay. I'm tilting. Remember, if you have trouble hearing me, or if you're liking the class, hello, let me know. Yes. Okay. So Vinegar. As I was saying before, vinegar and baking soda have actual proper chemical names, right? Vinegar and baking soda, those are what we call, those are just the common names. When we talk about the chemical name, this is acetic acid, okay, acetic acid. And then if you were going to call it by what's inside of it, okay, which would be naming off the hydrogens, the oxygen, as well as the carbon that's in it, that would be another name, okay? So essentially chemicals have three names, right? They have their common name, they have a chemical name, and then they have their name that names off the um, atoms, okay, the actual chemicals that are inside it, okay? So sodium Na, okay, sodium carbonate, okay? Now, let's get down to what's actually happening inside of our cup, or rather what happened in our cup. So we took the baking soda, I put baking soda down in the cup, right? That's this stuff. And then we added the acetic acid. So what happens is the sodium, this is the sodium's partner. The sodium actually switches partners, okay? And then this part of the acetic acid switches partners too, all right? But what's really cool and what causes the fizz in this reaction is that then after the partners switch up, we then get a further breakdown. This stuff does not stay this way. It doesn't like staying that way. It wants to separate further. And it naturally, remember how I told you the H2O2, our hydrogen peroxide, naturally separates out? Well, this naturally separates itself, but a lot faster than hydrogen peroxide. And so we get this compound then changes into, what's this? Some of y'all should recognize this. This is water, right? And then CO2, you should recognize that too. Most people kind of know CO2, carbon dioxide. And carbon dioxide is well, not always, but very frequently it's naturally found. It likes to be in gaseous form. And so you can imagine the carbon dioxide is that's the bubble, right? So you see how like they're switching partners and then they like split. It's amazing. That's what's happening when you mix just baking soda and vinegar, just that little stuff. This big reaction, all this awesome stuff is happening, okay? And so when we learn about baking soda and vinegar, we learn quite a few chemistry principles and concepts, okay? So now that we've had our knowledge fun, because to me it's all fun, right? Okay, now that we've had our knowledge fun, I say let's have our reaction fun and try to add some additional things to our control reaction and see what happens, okay? Hopefully it doesn't fall. Y'all are gonna tell me if you start to see it fall behind you, right? You are. Please tell me you're gonna like say something. Okay, just saying. I'm a little concerned. It doesn't seem like anybody's saying they're gonna tell me. Okay. So, anywho, let's get cracking. So we know what happens here. And we already know that a decision has been made by me that we're doing this times 10 comparison, right? So let's go ahead and get our reaction set up. In the past weeks, I've kind of done them separately. Well, not kind of, I've done them separately. Today, I'm going to, not completely separately, you'll see. I don't want to do too long of a setup. All right, so the first thing that I'm going to put down, all right, I'm going to put down our baking soda. I'm doing a level spoonful. I'm using my baking soda box. to let me level off the spoon. So I've got 2 spoonfuls inside of, okay, there we go, inside of each flask. This is our 150 milliliter flask, and this is our friend, the 500 milliliter flask. Okay, and you're probably thinking to yourself, that doesn't look like very much baking soda, Miss Steph. That's because I know what I'm doing. Just trust me. That's enough. That's enough to have some fun. Some fun. All right. Next, we're going to add our 2, and let's go for 3. We're going to add our food coloring. Remember, color makes life better, and it's fun that way. And since I believe that we make science fun, I'm always going to add some color here. Okay? Yes. Now remember the fizz, the bubble, right? The bubble is such a fun part of the reaction. Let's keep it. Let's see if we can make it last for a longer period of time. Okay? And so to do that, I'm going to add the soap. We've been using soap for the last several weeks, right? And just so that it's clear, every time I've used the soap, it is to capture the gas. It's not been the same gas in every reaction, but it is to capture the gas. All right, so I'm just going to do a little bit of soap. That soap's going to go on top of my food coloring. Okay, that was more than a little bit. It's okay for y'all to say so. He's like, what's she talking about? Actually, more over here. It's going on top of my food coloring. Now, as you can tell, the reagents that I'm like really measuring, right, are my core reagents, my baking soda and my vinegar. Okay, the baking soda I wanted to leave being the same amount so that you can really get a visual comparison of the impact of adding more vinegar, the impact of adding that 0 behind the amount of vinegar that we're putting inside of the container. All right, I actually want to do 15 milliliters of vinegar for my 1x reaction. Okay, and then I'm going to do 150 milliliters of vinegar for my 10x reaction. And this particular graduated cylinder makes it easy for me to measure that amount because this is a 250 milliliter graduated cylinder. So, I mean, this can handle it. And if you're wondering, is that really 100 milliliters? Not 100, it would be, it would need to be what? Tell me. If I'm doing 15 over here and I'm going to do 150 over here, how many milliliters of vinegar minimum do I need? 15 plus 150. Use your different strategies, right? That's 165 total, right? So I'm going to come in here, and remember, I'm not using the same graduated cylinder to measure the amounts, only because this graduated cylinder is going to measure the smaller amount more accurately. Okay, so if I really want to make sure that I'm getting 15, I want to use the right device. Once again, Miss Steph here. We are live on Facebook for our weekly Saturday Science with Miss Steph, y'all. I'm so glad that you joined me, that we've had so much fun for the last 69 episodes, people. I mean, I've had fun. Has it been fun for you? I hope it has. I really do. All right, so I'm up and away. I'm going to 150 milliliters. Slowly, right? Okay. 10 times 15 is 150. And then we just found out right? We just found out, or rather we can deduce, right? We can use our logic skills to say that there was probably about 200 milliliters left inside of this particular container, right? Because I needed 15 to go here. I needed 150 to go here. And then there's like plenty left, okay? I had more back there should I need it or whatever, but we didn't need it, all right? So now, a couple of things I want you to observe while we're rocking, right? We've got this here, right? We have our sample. And the thing with the soap and the food coloring, as you can tell, the soap clearly easily mixes with the food coloring very well. Whereas the baking soda, not quite as easily. All right. Another thing that we're going to probably see happen that I want to bring to your attention is that the soap is going to cause a bit of a barrier between, see the soap here is more of a layer. It's going to cause a bit of a barrier between the vinegar and the baking soda. All right. So it's going to react slower. Okay. The reaction should be a bit slower. One, because of the lack of contact, immediate contact anyway. And two, because the soap is going to help capture the bubbles, the carbon dioxide as well. All right. And we should get our friend foam, right? We know that foam is one of our indicators of a gas producing reaction, right? And foam, though it comes up, it moves a bit slower. Okay. Now, since this is still going, I say that we go ahead and let this go to and observe what happens. Now we're getting a little bit more of a side-by-side kind of situation. Uh-oh. Ah, lovely. Wow. So now you see why I was saying last week how Alka-Seltzer and water kind of mimics, because of what's in Alka-Seltzer and water, that reaction mimics, okay, or rather is similar to baking soda and vinegar. Because, right? Doesn't it look a lot like last week's situation? I mean, it does to me. Okay? So cool. All right. Now, let me bring it closer to you. Yeah. And as I pick it up, it is cool. Okay. It's not quite as cool as, and when I say cool, I mean temperature-wise. Okay. It's not quite as cool as the straight up just baking soda and vinegar reaction. Okay. So I imagine the soap kind of mitigates the level of how endothermic the reaction is. Okay, I think that's probably the soap. And with the speed with which it reacts, the soap is capturing the bubbles, which inherently is kind of slowing the reaction down a little bit. Okay. I mean, I can just sit and watch this for hours personally. All right. So if you have any comments or questions, remember y'all, when I'm on live, that's the time to ask your questions, right? Because I can answer your questions right then and there, or right here, right now, right? You notice how the me swirling it kind of helped produce. Now, I personally think, and hopefully you agree, because it's kind of more, it's a personal observation, but it's an objective observation, right? Since we did the reactions together in this same pan, we're really able to compare the magnitude, right? Because the one that produced the most foam, isn't that the bigger reaction? And don't we see that we have more orange foam than we have purple foam, right? So that's letting you know that multiplying times 10, one of our reagents really made a bigger reaction. Now, some of you may be so brilliant. Well, all of you are. But some of you may be thinking, well, what if I reversed the situation? What if I added 10 times the amount of baking soda to one specific amount of vinegar? I mean, you can try it. You can try it. But I can give you a hint. It's going to be a little different. It's going to be a slightly different reaction. Okay? Same chemical, like the same things happen chemically, right? The stuff that's on this board happens chemically, okay? However, the way that it interacts is a bit different as far as how many bubbles you get and all that stuff, simply because the baking soda, the amount of baking soda per the amount of vinegar you need is a little different. You actually need more vinegar per volume than you need of baking soda. And that's because the acetic acid is only 5%. Remember a couple weeks back when we used the higher percent, I broke out my special order hydrogen peroxide, and we were able to get a lot of foam from a little bit of catalyst. That's simply because the hydrogen peroxide that I ordered was 12%. Okay? And acetic acid, the amount of acetic acid that's in store-bought vinegar is only 5%. See? Right? So there's the rest of it's water. Okay? So there's not that much acid in here to react to the baking soda, right? And the baking soda is a solid, so it's like it's all baking soda. Does that make sense? Whereas this is a lower concentration of the acid. Okay, people, I'm getting really excited. And I could chit chat with you longer. But I think it's almost time for us to go. So before I go, I think it would be fun and fabulous and beneficial to see what would happen if I added just a little bit more vinegar to both of these. Because we've already done the test, right? We already did the experimentation portion of it, and now we can have even more fun. Right? And I'm sure you noticed that I look down when I measure that to do my perfect way that I measure, right? That's only because I'm just using the graduated cylinder as my delivery device. I'm not focused on using it as my measurement device. I just want it to be close. All right, people, here we go. We're going to finish out with this. Can you see? Can you see? Can you see? Hopefully you can see. We're going to finish today's lesson with one last look at our vinegar and baking soda reaction. What happens if I add even more vinegar to both reaction chambers? And there we go. We bring the reaction to completion. See how my swirl impacted that? All right, folks. Thank you so much for joining me. Miss Steph here. It's time to go. It's been an awesome, awesome, awesome adventure. Thank you for joining me for Science with Ms. Steph, episode 69, Baking Soda and Vinegar times 10.